Hey everyone, and welcome to this explainer. I am absolutely thrilled to have you here today because, well, we are tackling one of the most fascinating and game-changing topics of our modern era. I want you to take a second and just try to imagine a world without artificial intelligence. Like, really picture it. Imagine having to manually search through massive, dusty encyclopedias for a single fact, or driving to a brand new city without digital navigation to guide you. Imagine spending hours just sorting out the spam in your email inbox, or trying to translate a foreign language word by word with a heavy dictionary. AI is literally saving us immeasurable time, effort, and money every single day. So let's just dive right in and uncover how this whole shebang actually works.
To make this as efficient as possible, here's our game plan. First, welcome to artificial intelligence. Second, machines versus the brain. Third, how artificial intelligence learns. Fourth, the three domains of AI. And finally, AI today and tomorrow. All right, kicking things off with Section 1. Welcome to artificial intelligence, where we'll be demystifying AI. Before we look at where this crazy technology is going, we really need to grasp what it is at a foundational level, right? Let's break this down, starting with the word artificial. In this context, it simply means a system or construct engineered by humans rather than something that pops up naturally in the wild. Think of everyday stuff like artificial flowers or the artificial sweetener in your coffee, or even artificial rain created for agriculture. At its core, we're talking about a branch of computer science. But here's the kicker. Instead of relying on fixed, rigid instructions, it's built to step up and perform tasks that normally require human-like capability. Okay, so the second half of our foundation is intelligence. Now, intelligence isn't just about memorizing trivia. It's the highly dynamic ability to learn new things, to understand context, to remember past experiences, use reason, solve problems, and ultimately to make decisions. Basically, these are the exact cognitive abilities that you and I use every single day just to navigate the world around us. So what happens when we put those two definitions together? Well, artificial intelligence is exactly what it sounds like. It's a pretty straightforward equation. Artificial plus intelligence equals intelligence created by humans. It's the ability of a man-made machine or computer program to actually think, learn, and make decisions just like a human being would. Honestly, it's a completely different paradigm from that standard, predictable computer sitting on your desk right now. Moving right along to Section 2, Machines versus the Brain, exploring the intelligence gap. To truly appreciate this massive gap, let's think about how normal, everyday machines operate. A traditional machine, like a basic calculator or a traffic light, is entirely rigid. It only follows fixed rules perfectly written out by a programmer. If you type 5 plus 8 into a calculator, it processes that specific instruction and always spits out 13. It doesn't think. It doesn't learn. It has zero experience. It just follows the command. But artificial intelligence? Now that's a different story. AI can look at 10,000 different pictures of cats, learn the underlying patterns, and then recognize a brand new, never-before-seen image of a cat. And it does this without a programmer having to write code for every single furry feature. It gives a smart output, and it actually improves with experience. And this brilliantly highlights the gold standard we are aiming for here, the human brain. 86 billion. That is the jaw-dropping approximate number of neurons or brain cells packed into the human brain. These cells are constantly communicating, which is what allows us to observe the world, use logic, and analyze our surroundings. I mean, think about it. You look up, you see dark clouds, your brain instantly remembers a previous experience with dark clouds, it predicts that rain is coming, and you decide to grab an umbrella. Traditional machines absolutely cannot do this. AI is attempting to bridge this exact gap. Let's dive into Section 3, how artificial intelligence learns. It's all about experience versus data. We know AI is designed to mimic the human brain, but what are the actual mechanics behind that? To figure this out, let's start by looking at how humans learn. It's incredibly visceral and based on real-world consequences. A perfect example is a kid touching a hot stove. Step 1, the child touches the fire. Step 2, they feel intense physical pain. Step 3, their brain's neurons fire off and remember this highly specific event. Step 4, the child never touches the fire again. We call this learning from experience. Now, AI tries to imitate this exact human learning cycle, but obviously it doesn't have biological brain cells, so instead, it uses what we call artificial neural networks. Let's walk through those steps. Step 1, you show the AI 10,000 images of dogs. Step 2, the artificial neural network crunches all that data and learns the patterns and specific features of what makes a dog a dog. Step 3, you show it a completely new random image. Step 4, the AI predicts, hey, this is a dog. It's learning, not from painful life experience, but from digesting massive amounts of data. Actually, let me pause right here because I really want to emphasize a crucial distinction outlined in our source material. While artificial intelligence is incredibly smart at predicting patterns through complex algorithms, it does not think exactly like us, not even close. AI does not have emotions. It completely lacks consciousness. It doesn't have feelings, and it has absolutely zero human common sense. It is purely an engine that learns patterns from data. Which brings us to Section 4. The 3 domains of AI, namely data, vision, and NLP. You can kind of think of these domains as the different senses that give AI its incredible capabilities. The absolute bedrock, domain 1, is data. In fact, the source material calls data the food of AI. Data is just a collection of raw facts, so we're talking lists of names, student test scores, photos, audio clips, or hospital records. And the golden rule here is super simple. More data equals better learning, which in turn equals much higher accuracy. Without this food, the AI engine is essentially starved. It simply cannot run. This is the exact fuel driving your Netflix movie recommendations, our daily weather forecasting, and even complex hospital disease predictions. Domain 2 is computer vision. This is the mind-blowing ability of computers to understand images and videos just like you and I do. Think about human vision. Our eyes capture light, send signals to our brain, and boom, we recognize an object. Computer vision simply swaps out the biological parts. A camera captures the image, feeds it to the AI, and the AI identifies the object. This is literally exactly how your smartphone's face unlock works. It's how self-driving cars see the road, and it's how cutting-edge healthcare systems spot anomalies in medical x-rays. Then we have the third domain, natural language processing, or NLP for short. While computer vision allows AI to see, NLP is what allows it to understand, read, write, and speak human languages. So, whereas computer vision works with images to detect objects, NLP is busy working with text and speech to understand words. This is the absolute magic behind Google Translate seamlessly shifting between English, Hindi, Punjabi, Japanese, and French. It's the underlying engine powering voice assistants like Alexa and Siri, and those incredibly smart chatbots like ChatGPT. All right, our final section, Section 5, AI Today and Tomorrow. Let's look at the real-world impact. So we've talked a lot about the theory and the underlying domains, but what I really want you to take away from this explainer is how this technology is actively impacting your daily life right now. AI is already operating on a massive, largely unseen scale across major industries. In healthcare, we've got robotic surgery and rapid disease detection. In education, smart classes and AI tutors are providing tailored, personalized learning. In the banking sector, AI is quietly working behind the scenes on loan approvals and sniffing out massive fraud. And in agriculture, farmers are using AI for crop monitoring, pest detection, and smart irrigation. I mean, it is quite literally everywhere. And it's also deeply embedded in your own personal, everyday routine. When you commute to work, Google Maps and smart traffic signals are guiding you. When you kick back to relax, AI is powering those perfect recommendations on Netflix, Spotify, and YouTube. When you're shopping on Amazon, it's right there suggesting products you might like. And if you have a smart home, AI is listening through Alexa, adjusting your smart AC, and keeping you secure with smart door locks. It really is the hidden engine of modern convenience. But the future? Oh, the future is awe-inspiring. We are looking at a fast-approaching era of hyper-personalized medicine and wildly accelerated drug discovery. We're going to see fully autonomous vehicles smoothly mastering traffic control. We'll be deploying autonomous robots for deep space and planetary exploration, working alongside incredibly complex systems dedicated to environmental protection, systems forecasting disasters, and predicting the climate to keep all of us safe. Now, let's just quickly summarize why we rely on this tech so heavily. The advantages are unparalleled. AI works 24/7 without ever needing a coffee break or feeling fatigue. It drastically reduces human error. It can process unfathomable, massive amounts of data in just a fraction of a second. It handles all those mundane, repetitive tasks we hate doing, and overall, it massively increases our productivity and supports innovation across literally every field. However, to be completely impartial here, we really have to acknowledge its critical limitations. AI requires massive amounts of high-quality data to even function properly. Also, it is extremely expensive to develop. We also have to face the economic shifts, like automation undeniably reducing certain types of jobs. On top of that, there are ongoing security and privacy hurdles to manage. And perhaps most importantly, because these models learn entirely from historical data, they will blindly replicate any flaws, inaccuracies, or skewed human biases that are present in that training material. Which leaves us with a final, pretty provocative thought to ponder. We know that AI is essentially a mirror reflecting the data we feed it. So, if artificial intelligence relies entirely on our human data, is it inevitable that it will inherit all of our human flaws and historical biases? And ultimately, can a machine that flawlessly recognizes patterns, yet entirely lacks human common sense and lived experience, truly be called intelligent? Thank you so much for joining me on this explainer today. Keep asking those big questions, and I'll see you next time.